So you just watched a video of proving the law of cosine, so now we're going to see practically how we can make this work. And so just to clarify, law of cosines can be used when we know an angle, an included angle between two given sides. So side, angle, side, we would use law of cosines. And we would also use law of cosines when we know the length of three sides. So for side, side, side. These are the two cases where we'll use law of sines. All the other cases we'll use law of cosine. All the other cases we will use law of sines, except for an angle, 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 where that cannot be proven. So we can't solve the triangles in angle, angle, angle. Okay, so let's actually just real quick remember the formula. Like if I'm given side A and side C and side B, and I have to actually use the law of sines. So I'm looking, the first thing I actually can find using the law of cosines is the length of A, the length of BC right here, so that would be little a. And I would use that by knowing the other two sides and knowing angle A, so the included angle. Okay? Now let's say that I actually, if I actually knew angle B this time, and then I had little side C and little side A, well then I would be looking for side length of B first, and I would know the other two sides, and I would know the included angle. I would know the included angle. And again, I can use it for, if I was solving for C, that means I would know the other two sides. I would know B squared and I would know A squared. And I would plug that in. And I would be looking, and I would also have the included angle of C. Okay, so there is just a brief overview of the law of cosines. Let's see how it plays out. So here I have some measurements. It says angle A is 40 degrees. It says side B is 6. And it says side C is 7. So I have side, angle, side. If I have side, angle, side, the first thing I'm going to do then is find the missing side. The first thing I'm going to do is find the missing side. So I set this up. So if I'm missing A squared, that means I have B squared and I have C squared. And I'm looking for the length of A, and I have the included angle of A. So if we actually solve this, I have the two sides, 7 squared plus 6 squared, minus 2, 7 times 6 times the cosine of the included angle, which was 40. And we type all this in, 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of 40 gives me, A squared gives me 20.65, and we square root both sides. Now I really want to take all my decimals, so since they're still all in the calculator, I'm just going to take the square root of my last answer. And that gives me A to be approximately. Now I know it seems crazy, but I really want you to write down all these decimals. The reason why is we will get a more accurate angle for angle B and C when we use the entire approximation here for A. So, okay, we just solved A. Now we have all three sides of this triangle. Now what we're missing is the angles. But if I know all three sides of the triangle, then I can apply law of sines to find one of the other angles a lot easier than I can use law of cosines again. So the second step, we're actually going to apply the law of sines to find the next angle. And you need to first find the smallest angle. Write this note to yourself. Find the smallest angle first after you've found the third side. So find the smallest angle. And now the smallest angle will always be opposite the shortest side. So 6 appears to be the shortest side. Across opposite of 6 is angle B. So we're going to find angle B first. So we use the law of sines. And we use the one we know, which was A, and all these crazy decimals. Okay, so we're going to solve this. So we take 6 times the sine of 40, divide that by all these crazy decimals, and I want to find the angle B, so I have to take the inverse of that answer. So angle B gives me 58.1 degrees if I round to the nearest tenth. So then angle C is real quick to find. We can take 180, subtract the two angles that I know. Angle A was 40. So 180, subtract 58.1, subtract 40, gives me 81.9 degrees for angle C. Okay, so I've solved the triangle because I found side A to be approximately, now we can round it to 4.5, angle C 81.9, and angle B was 58.1. So I have completely solved this triangle because I found all missing angles and all missing parts. So let's look at an example of side, side, side. So let me grab another sheet of scratch paper here. Okay, let's look at an example of side, side, side. So here, okay, so we'll call the length here of C will be 21.5, 10.3, and 16.7. So the note in side, side, side that you want to write down right now is that you need to find the largest angle first. You need to find the largest angle first because we're using law of cosine. And remember, cosine is bound between 0 and 180, so it makes sense to find that largest angle if we can go all the way up to 180. So we're going to find the largest angle. Remember, the largest angle is across from the largest side. So the largest side is 21.5, so I'm going to first find angle C. So it's a little bit harder to solve than the last problem. So I have side, 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 so I have to use the law of cosines. And we have C already, which is 21.5 squared, which equals my other two lengths, 16.7 squared plus 10.3 squared minus 2 times 16.7, whoa, we're out of times, where was I, 10.3 cosine of, and we're going to be finding angle C first, because that's the largest angle. That looks like a beast of a problem to solve, but we can do it. So the first thing I'm going to figure out is 21.5 squared gives me 462.25. I'll do 16.7 squared plus 10.3 squared gives me 384.98 minus, I'm just going to simplify what's in front of cosine of C, 2 times 16.7 times 10.3 gives me 344.02 cosine of C. Remember, that's multiplying. So just go back to algebra class, subtract 384.98 from both sides. So 462 subtract 384.98 gives me 77.27 equals what's left over here, negative 344.02 times the cosine of C. So to get the cosine alone, we'll divide out both sides. So the cosine of C will equal negative 0.2246, and it goes on. But how do we get into that angle? We take the cosine inverse. So second cosine to get the cosine inverse, and we get angle C to be approximately 103 degrees. So we found angle C to be approximately 103 degrees. So we found one angle, and I'll come over here and fill that in, 103 degrees. So now I can actually use the law of sines to find another angle, and then we can just do triangle sum to find the third angle. That would probably be the easiest. So law of sines, we do sine of 103 over 21.5 equals the sine of, doesn't really matter, angle A over 10.3. If I solve this, we have 10.3 times the sine of 103 divided by 21.5 gives me 0.46679, but I want the angle, so I need to take the sine inverse of that answer. And so angle A gives me approximately 27.8 degrees. And then angle, so what angle is missing? So if that's 27.8, then we're missing angle B, and angle B, real quick, 180 take away 27.8, take away 103, gives me 49.2 degrees, and I've solved this by side, side, side. Now, there is one special case that happens with side, side, side that I briefly want to talk about, and that is when we have the three sides of a triangle. Okay, and you need to remember the triangle inequality theorem from geometry, which states the sum of two sides must be greater than the length of the third side. The sum of two sides must be greater than the length of the third side. So if I add up these two sides, 15 plus 25, what do I get? I get 40. But that's not greater than the length of the third side. That's actually equal. This actually, even though I drew it, it doesn't actually make a triangle. So anytime you take a look at a triangle, add up your two sides and make sure, add up two sides and make sure they're greater than the length of the third side. Now you need to check all sides and make sure. So in this case, this would not be a triangle, so we say no, zero triangles can be made. There's just no way to solve, there's no way to solve the rest of this because it didn't even make a triangle. Okay, so that's it for law of cosines. Go ahead and work on your worksheet. I believe it's T7, and give those problems a shot.